So today's class is really going to be taking a look at, as COMCheck as a resource, looking at, best practices for understanding and using COMCheck and different compliance alternatives. So it's going to be a fun class. I think it's going to be an engaging class. If you do have questions, please make sure you use the chat, use the Q&A, raise your hand. We can talk through the process. Hopefully it's a useful conversation. I think it's something that I personally think is very important as building officials to understand so that we know how best to evaluate a COMCheck project, as well as how to help or what are some different resources to help uh, our builders who come in or designers who come in with questions. So one more step. So for those of you who don't already know who we are, we're with the Minnesota Energy Code Support Program. I know we always get new people all the time, and we're here to provide different outreach and information, education, resource, and tools for building departments and contractors, design professionals across the state, and how to properly enforce and apply requirements of the Commercial Energy Code. I'm going to go ahead. I'm having some camera problems, so I've got two cameras, and the one that's working is that one. And the one I'm looking at is this one. So I'm just going to go ahead and turn my camera off. So you won't miss anything, trust me. So to help with that conversation, again, we put together a website. If you haven't checked out our website, you can go there, check out our technical resources, our upcoming trainings. As well, in that technical resources, you'll find different newsletters, inspection guides, checklists, and information regarding COMCheck, the use of COMCheck. But if you do have particular questions, always feel free to reach out to us. And as you know, one of my fundamental concepts that I like to talk about is that if we understand the why behind a question, we can better apply the how, right? And I think that's a good way to look at COMCheck. Now, I've just uploaded it for those of you that want to download it, kind of follow along, take notes as we go through it. But when we think about why we have COMCheck, well, that's because we have a building code. The building code tells us we need to find minimum ways or basic ways and uniform expectations for structures that are built throughout the state. And we give it a commercial energy code, which is, because we're trying to not just build a building that's safe, but a building that also does what we expect it to do, which is to control heat loss, right? The code is all about control. And in the energy code, it's all about heat loss control. It's about climate change control. It's about illumination and the role of different components in facilitating that long-term goal of building a efficient, effective building. Now, it's not about one energy source versus another. It's all about how to make that building the best building it possibly can be. You understanding that it's going to be there for a while, right? And so when we think about those building systems we've talked about before, I see life in a series of simple things, and simple things to me is the four basic pillars of the building system, right? Or of the energy code, which the energy code looks at the building thermal envelope, it looks at mechanical systems, it looks at service water heating systems, it looks at power and lighting controls. And within those concepts, it's looking to make sure that we have some basic expectations for how they're going to effectively work together to build an efficient building. Now, when we do plan review, we've talked about plan review a lot. One of the things we do is we always check to make sure that we're getting the appropriate information. Now, the first thing we always remind you is to double check the code edition. This is critically important for understanding something like COMCheck, because if we're not making sure that we're taking the bull by the horns and using the 2024 edition of the Minnesota Commercial Energy Code, then we're probably going to get a COMCheck that's not going to be accurate, right? And then the second piece of information we need to have is that compliance path, right? And with that compliance path, we can then determine a little bit more about how that building is going to reach code compliance. We see here listed as an energy compliance path, section 4.211. Now, the only problem with that is 4.211 is actually just telling me it's a new building, right? The compliance path is going to be one of those three options of either prescriptive, energy cost budget, or performance rating. Now, remember, prescriptive is going to be that process where we're using a building or using the code. We'll talk about more about that. But, to just say I'm using a new building is not going to be the way to describe that. We'll have to send in some report that says, hey, I need a little bit more information. I'm going to make some assumptions as I move forward, but I'm going to need a little bit more information. One of those things that helps us to understand maybe where the plan is going, where the project is headed, is when we see things like a COMCheck. A COMCheck is going to be a resource. It is not a solution. It is not a guarantee of something. It is just, again, a report that's generated to guide or assist in understanding how the building performs. And so it is its own caveat within the prescriptive compliance path. So once in a while, like the image here where we said that we're complying, where you're looking at the R value, when we see that COMCheck, then we know that we're going to be utilizing most likely a trade-off compliance path, right? Now remember, compliance paths in the energy code are prescriptive, energy cost, and performance. Prescriptive is going to be give me that list of expectations, and I'll follow that table. And because the energy cost is looking at how much does it cost to operate that building for a year versus a reference standard. Performance is doing a similar mathematical calculation about the performance rating of the building on some kind of a scale. But really the one we're talking about because of the COMCheck is the prescriptive. Now, we know that when we say prescriptive, that means I'm going to follow one of two options, right? Now, I want to take just a quick second to remind us that the code says that these types of building projects have to comply with the energy code. If we're doing a new building, this is my duh moment, right? Yep, new building has to follow the energy code. If we have an addition or a new portion of a building, it has to follow the energy code for that specific area. When we install new systems, new equipment, we have to evaluate it based on certain expectations, which we may or may not receive a COMCheck to help document that compliance, as well as when we start thinking about alterations or changes of occupancy. If we transition from a warehouse to a office space, then we have changed that occupancy, and there's a lot of expectations to come with that. We don't just get to say, hey, well, it's an existing building, I'm just going to start using it, right? We have expectations, and we understand as building code officials that includes a myriad of things, right? Could be fire, could be accessibility, could be a variety of things depending on what we're transitioning from when we talk about that change of occupancy. And so sometimes we'll see where COMCheck can be a resource for a design coming in. But when we really think about COMCheck, again, COMCheck for the most part was designed to be a tool used when evaluating a building thermal envelope, right? When we look at the code tells us that in section 5.22 that our building thermal envelope has to comply with either the prescriptive compliance path or the building envelope trade-off path. So really, what we may end up having is actually 4 compliance paths. We have the prescriptive building path, we have the prescriptive envelope path, we have the building trade-off path, we then have our cost budget analysis and our performance path. But ultimately, what we're looking at when we look at the expectations for the building thermal envelope is that we have mandatory provisions, prescriptive, building trade-off, and submittals. And so that tells me which of the tables I'm going to be using or how I'm going to be using those tables. Knowing why I'm looking at them, now I know how. I can start to better understand how I'm using them. Now, section 5, if we're doing prescriptive table only, then every value associated with a component listed, every wall has to meet the requirements of the table, right? When we start talking about what makes up that wall, we choose either to look at a minimum R value or a maximum U factor, right? That minimum R value is the thermal rating value for one particular piece of material, right? And a specific one piece of insulation has a R value. My shirt, as low as that would be, is going to have an R value, right? When we think about the U factor, C factor, F factor, which are all really the same thing, just how different thermolytic calculations. But when we think about those U factors, that U factor is looking at the entire assembly. So it's not just the insulation, it's now the insulation plus the wall, plus the exterior cladding, plus the interior wall surfacing. All those components together get aggregated into a uniform maximum U factor, right? That's these are the values we use to measure thermal loss through a particular material or assembly. We normally associate that when we talk about these opaque systems. We normally associate that with insulation, right? That's our normal go-to is insulation. But not all insulation is equal because not all insulation has the same R value. It has different qualities and expectations because not all installations of insulation are the same, right? Because we're going to be looking at how do I get an R value versus a U factor. Now, we've talked about this before, and I think this is why it's important. I think this is important foundational understanding as we look into COMCheck. When we start to calculate that U factor, we're looking, again, like I said, at all the materials utilized in that wall assembly and looking at their total individual R values and calculate them over the relative or average area of that assembly, right? So if I was looking at one moment in time, one space in time, I would see that the cavity has this is its area weighted R value, right? And this would be the studs area weighted R value, right? But what we do when we calculate a U factor is we start, and what the purpose of the COMCheck is to do is to look at the entire wall or an entire assembly and say, okay, how many 2x4s? How much insulation? How many windows? How many doors? Right? And then we do that total math calculation. So instead of having to do this type of evaluation every time, we do COMCheck to do that quick math calculation. Right? That's the point of COMCheck or ResCheck if you're looking at it in residential terms. Now, I will tell you, residential and commercial ResCheck, COMCheck are very similar, and we'll talk more about ResCheck maybe in a couple of weeks when we get into some more residential topics. And we can see the differences between the current and the proposed changes that we see in the code. But right now, if we're applying today's commercial energy code, that option for a COMCheck is there to help us do the math. And we'll look at that in a second. Because what we're doing is we're saying all these materials, I can either go with the R13, right, plus 3.5 continuous, which is my design, but my design, if I'm looking at a wood frame wall, does not comply. I need to double my continuous. Well, I don't want to, right? And so I want to see what can I do. I have a very specific type of continuous insulation. I've got some other areas. What am I able to do? Well, by doing my math calculation, I can see a U factor is 0.057, which still doesn't get me where I need it, right? So I'm not going to comply with my wall design. But what do I need to do to comply? So that's when I start adding and changing things. I can change either my insulation on the in the cavity or in the continuous insulation and start to get different values. Right, so I have that ability to be a little bit more flexible in my design to get to that area weighted U factor. Now, one of the things, if you don't want to do all the math, you can always go to the back of the book. In Appendix A, it gives a list that comes from the 2021 ASHRAE Book of Fundamentals, a list of different systems and their relative pre-calculated U factors, right, where it's gone through the system and said, hey, if I take a single layer of metal building roofing, and I add some insulation to it, what is its U factor, right? It gives me a pre-calculated series of materials. My alternative would be to go to the COMCheck. Now that's found at energycodes.gov. I checked this morning. It still exists as a function of DOE's website. And so in that website, we're going to find COMCheck when we go look at our technical assistance programs, right? There are two types of COMCheck that we can look at. There's legacy COMCheck, which is, a good older alternative, right, that we can log into. And again, we can log in. You can use the registration to get a user account is free. The only detraction that I really see with old COMCheck is that you can only look at one project at a time. I've included in your slides a series of slides associated with legacy COMCheck. But I'm going to go ahead and jump. Now, for those of you following on that handout, I'm jumping from slide 31 to slide 52. I'm not going to go, we can go over 32 through 51, look at the old COMCheck or legacy COMCheck, but I want to focus in on new COMCheck because I think it's a different resource or a better resource for us. Because as we look at the big thing about new COMCheck, not that the math is any different, but the design is different, the layout, right? I can create and maintain a list of projects, right? I'm not just looking at one project and then when I'm done, I'm gone. I have a list. Now, the thing to think about, and I think this is important for us to understand, we can share COMCheck with other people who have COMCheck. So that if a team needs to look at it, let's say I'm working with a building department, or if I'm working with a department that has a larger department that has multiple people, or let's say you call and say, hey, Josh, I got a question. As a designer, you can call me and say, hey, Josh, I got a question about my COMCheck. Can I send you a copy? You can use this share button to send it to me, to email me email me access to your COMCheck. And then one of the things that I think is important to understand is you can also download them. So let's say I build a greenhouse that meets the energy code and I want to download it because I don't need it for now, but what if I want it later? I can download and then re-import that project later, right? So I can save my work and come back and say, okay, well, I was going to build this in Rochester, and I come back 2 years later, 3 years later, and say, well, I've decided I'm going to build another one in Duluth. I can come in and upload and download. GH won't comply. Oh yeah. So again, one of the things we start talking about is how do these systems work? Can I see a hand? Thought I saw a hand. So again, I can look at a variety of materials, or not variety of different projects, variety of different codes. So as a designer, which I know sometimes we get some designers on, they can utilize this and say, okay, I'm going to build my convenience store to the 21, and I'm also going to build that same convenience store or something similar to the 24 Minnesota. I can keep both in the system, copy, paste, duplicate, create new, whatever I want to do, because I have that is an option under the new COMCheck system. Right? So so again, I can choose new projects, old projects, copy projects, whatever makes sense. Now, I will be honest, I have not looked at sample projects. It's just never come across my mind, but maybe I will, now that I'm thinking about it and noticed it this week. But what I'll do, let's pretend I'm making a new project, right? I'm going to begin to type in. This is the first page. You notice that all the values are on the left. Now, if you're looking at legacy COMCheck, I will jump up to that real quick. All those component types are at the top of that page, right? And you'll see a very similar process to it, but that'll be hopefully my only digression back to old COMCheck. But when I start thinking about what I'm looking at, I have the ability to type in different information, right? I can evaluate my location. I can type in the location. As I type in Elk River, I start to see there's a variety of different elks out there, right? Or rivers. And so I can select the proper one. That's going to bring with it by adding the appropriate community, it brings with it the climate zone values, right? The details associated with that particular area from the code. I can also select my code and see that at the very bottom is my 2024 Minnesota Commercial Energy Code. Now, I'll tell you what, to me, this is one of the best things, this is a great opportunity that the state took advantage of to create a state-specific energy model or energy compliance tool, right? Because otherwise, you'd have to go with a 2019 standard and then have some kind of modifications as based on whatever we're doing. But this incorporates all the requirements of the 24 Commercial Energy Code. And so that way, when a project comes through, you can very easily see, does it comply with Minnesota's requirements, or did we forgot we used 2019 national standard, and by doing that, some of those values are not going to be correct, right? I was talking to some other jurisdictions where they've modified the 21 to go to the 2018 or 24 values. They cannot use a simple standard. They have all kinds of problems, right? I've used this example before, talking about this. The city of Aspen, Colorado, because they chose not to do their own version, like Denver and some other communities have, like Minnesota, their compliance path, you have to pass the 21 by 40% or better. Well, we'll explain that to somebody. Well, yeah, you have to pass it, but you got to beat it by 40 or more. Well, then, so why am I even using this, right? This way we are able to use a resource. Let me zoom in just in case you can't see it. I know some of that text gets small after a while. So we can select the appropriate value to get the right thing, the right code. So now that I've got my building, I'm starting that process. I now can pick a project type, right? I can pick, am I using a new building, an existing building, right? An addition, an alteration. Those are conversations I can start to ask. I can also go down here and start inputting the area, the building area. This is where I'm going to put in. Is this a retail space or a storage area? Is it commercial? And what is that? What is its space conditioning? That's really selecting which of the three tables am I going to be applying or using, right? And we can add multiple building areas so that, again, if we have a larger facility, let's say we've got now again, we're using this example of a simple convenience store. It's got a retail space. But if this was a garage, let's say this was an automotive repair. So I may have office space. I may have, a retail space. And I may have, again, a semi-heated garage area. I can pick through, when I click on that add building area section, I can start to select what are those different options within the code for me to identify, right? Is this an office or is this something else? So again, I can start to add in those specific expectations for that building. As I move down the table, right, as I move down the process, I'm going on the left-hand side here. I've completed my project information. Now I get into the envelope. The envelope we see is broken into four different types of assemblies, right? The roof, the exterior walls, the floors, and the basements. So what I start to do is I start to add those assemblies. Now we see here I've added some already, but when I click that add button, I have the ability to start adding components, my roofing system. I can explain to it the area. Now remember, I'm doing the area of that system, not the area of the building, right? The area of the system. So like the skylight, I've installed a small skylight, 154 square feet. I can put in the U factor, the solar heat gain values, right? I can put in my insulation and what my values are. I am putting in these numbers so that the code can then start to build an idea of what's going on. Now, let's say, again, I have more than one roof structure or more than one type of insulation in that roof. I can start to add multiple layers, multiple roof systems, or I can I can do an aggregate, maybe an R value. If I know it's R49 above, but then I've got some R60s that are done in a different part of the building where we've got a little bit different design, then I can make those accommodations, right? And the computer will do that large mathematical area weighted calculation. That's the whole point of COMCheck, to do the math. Right? When I start to look at that envelope, I start adding exterior walls. I start deciding what construction methodology, right? Is it wood frame, steel frame? Is it block wall? Is it a concrete wall, metal building? And I can identify, once I start making those selections, I can identify the area. Remember, I'm looking at the length of the wall and the height of the wall, not the area of the building, right? This is the gross area of that wall system, because it's doing the math and saying, hey, if it's 16 on center, then 25% of this wall is going to probably be steel. The other 75% is going to be cavity. And then I can start to say what I can put in, and this is important. I need to put in that orientation, because the code is going to ask what's the orientation as we think about the impacts that orientation can have on wall design, especially windows. I can put in the cavity values, put in the continuous values. And again, I can put down, what is the relation between associated with this system and the space that it's around? Is this directly on the exterior wall? Is this part of a semi-heated space? Is this next to unconditioned space? So the code kind of gets an idea of how is it measuring that system in relation to let's say we require, and just to use an example, let's say I'm designing the building to have R30 on the exterior wall, but in the space separating my building from my let's say my workspace, my garage area for my, if I was doing an auto facility, then I would call that a semi-heated space. So then it's going to calculate that wall and say, okay, it's not required to have the same level of separation that we see with an exterior wall, right? Because it's, again, it's moving into that semi-heated value. When I keep going through that process, I can start adding doors and windows. Again, I can pick the framing type, the size, the types, the projection factors. If there is an NFRC value, they can input that number and get that value automatically pulled over. A lot of times I see this, where they just type in a value associated with what they've spec'd, right? 0.3 window, 0.21 solar heat gain, and then they give me some kind of an idea of what it is, right? Is this storefront A, or is this, casement A1? Whatever that is, they're going to give me some kind of a description. A lot of what we see in this is user defined, right? I say that because I want you to understand this is the opportunity where people can say, this is a door, this is a opaque door, this is a the main door. They can start to create those terms so we can better determine what it is we're looking at, right? And again, we can keep going on. We can do floors, we can do slab on grade, heated, unheated. Now, this is when we're looking at that perimeter, right? Before, we've always looked at area. Now we're looking at just the perimeter for the slab on grade. If we're doing a basement, it'd be area. But again, we're looking at that slab on grade perimeter. So again, what is the length around that perimeter? And then we can, again, start to decide, is this an automotive facility? Is this a is this a residential? Is it non-residential? What's my depth of installation, right? Those are values I can start to input and hit that apply changes. Ultimately, what I end up creating is a series of wall assemblies, right? As we can kind of see here, we've got an exterior wall with a window and 2 doors. We got one wall with a wall, 2 windows, and 1 door, right? We got a wall that has no doors or windows, and one that has a window and a door, right? So we have different designs based on the way this building is laid out. What you'll see here is I put north on all of them. Now, I'll tell you this now. If doing this, I get an error, right? It wants to know that this is not all part of one assembly, right? It's looking at each individual grouping, right? The exterior wall, and this goes under that wall, right? That's what those little arrows represent. That I've grouped these under one wall system. Then it will ask me to verify, to clarify those orientations. And one of the things that I think is important to understand is this all can facilitate. This works harmoniously together with our mechanical design. We'll talk about mechanical design next week. But this is the opportunity for us we could create this and then send this into our mechanical designer, and they can see those wall designs. They can start to calculate, what kind of heat gain are we going to get from this wall based on its elevation, or from these windows based on their, solar heat gain coefficients, their U factors. They can put all that information into the either the ASHRAE, manual in, or they can put it into another, software calculation for heat and cooling load. So that's our envelope. We can move on to our interior lighting, which we'll talk about as we go on, but we can start to add those spaces, right? We've added a retail space. We start to identify of that retail space, how much of it is inside one of our top lit, side lit zones. An opportunity for us to, again, give that information and put it onto a simplified report. Now the computer will do the simple math, but again, this is based on user input information, right? I'm telling it, this is how much side light I have, how much top light from a skylight I have. I can also tell it the type of fixtures, right? And after I've installed those fixtures, right, I must have skipped over that one in the making this PowerPoint. I can also go and tell it the controls. So I've got this LED light, that's one of my fixtures, and I can tell it what type of control I'm going to have, right? Am I going to have I'm going to have local control with an automatic partial on that also does an auto off at 50%, right? That has some type of timer or occupancy based sensor, right? LED number 2, I can start to put in all of the control sequences or control the requirements that we see in the code for each of those fixtures in my design. Ultimately, I'll be running into, again, we'll be talking about interior lighting in a couple weeks, more in depth. But again, I've got my area. I know what I'm using as far as my space by space method of calculating allowable area, my number of fixtures, or my types of fixtures, my number of fixtures, my number of watts to show me how am I going to demonstrate compliance with the lighting requirements and control requirements of the energy code. Same thing with exterior lighting. You start to calculate, okay, this is going to be my parking area. This can be my canopy. The one thing I can start to put in is that lighting zone, right? I can select which of those lighting zones I'm actually using. Again, remember, this might be a conversation between us and our zoning departments on what is an appropriate lighting zone. Otherwise, they're going to be inputting that value to give them the calculation they're looking for, right? We can go into these areas as we add areas as we saw there, exterior building lighting areas. We can start to select, is this a parking area, right? I can change the square foot. If I had a square foot, 4 square foot of parking area, I think I've got a problem, right? That's not going to be adequate. But I can start to change it. Is this going to be an ATM area? Is this going to be a landscaping? Is this going to be a pedestrian tunnel? All those different considerations that we find in the exterior lighting options to help us better refine what we're looking for and how to most effectively allocate our lighting systems, right? And so again, what I'm ultimately going to be finding is, like we said earlier, I've got a parking area, I've got a canopy, right? We know that probably for this convenience store, we're going to have probably a little bit more than just an entry canopy. We're going to input, some facade lighting. We may have, again, a service canopy area that's different from our entry canopy. Entry canopy being the area that we walk under as we enter versus where the gas pumps are. Those kinds of considerations get input at this level so that we have a complete list of the exterior lighting expectations. We start looking at those mechanical systems, and again, these are user-defined terms. So this is when we start seeing different systems input into the design. So they can label them. This is HVAC 1 versus 2, or however they do it. This is telling me this is a duct. As they input that information, they'll add HVAC. It'll ask questions. Is this heating? Is this cooling? Pick one of those duct systems. What's the size? What's the fuel type? Again, these are user-defined values. So they put in, is this 80% or 96.5, right? So that way that information can come from, the mechanical engineer. Now, I got a question about who fills in these specific areas of the COMCheck. That's going to, again, depend on the size of the project and the type of team. For the most part, for smaller projects, I usually see an architect do it. A contractor can do it. That's where I think it's important to understand this system. And again, where I can share this, right? I can be the architect and say, let's say it's a large facility and I've got an electrical engineer or electrical contractor on site. I can share that with them and they can input in the design process those values for electrical or mechanical information, right? If I've got a mechanical engineer, he can have access. I can share this with him and he can go in and say, hey, I see that I can look at all those. I picked the wrong one. I can look at all those wall details to help me better refine my load calculation. And then as he selects those pieces of equipment, he can input that equipment into the system, right? So again, it gives us that flexibility to where we can cooperatively work on a project. Now, again, if it's a small project, it might just be the contractor. A contractor can put this information. Remember, to get that registration to be able to use the system is free. This is a free software. And so anybody can use a building official, I had a question earlier about, as a design firm, uh, you know, what's the best way what makes best sense? Do we do one login or everybody has their own log? I tend to, just because of my mentality, I want everybody to have their own login. Why not? It's free, right? And then if you wanted to share projects, let's say you're in a team, let's say you're in St. Paul and you want to share this COMCheck over to another plan reviewer, you can do that because it's free, right? And then you can just remove that share later. You can, from both sides of the share process, right? But again, this information will be input by someone, either the mechanical designer or the contractor or the architect. And again, what we're going to be doing is looking at it now as plans reviewers to verify compliance. Now we see here these little X's. These X's that we see are specifically related to the checklist that comes with COMCheck. And so we can start to go into these. A designer can go in and say, yeah, do you meet the requirements of the equipment efficiency for a gas-fired duct furnace of 80%? They can say, yes, look at page M1, right? Because this is not doing anything for the mechanical and lighting. The only reason it has mechanical lighting is to provide us additional ease of explaining the system. It doesn't do a mathematical calculation, right? And so what we'll see is I can put in these little notes and I can go down. Does it meet where the same next line says equipment efficiency does a 13.4 SEER, right? I can click. If I push this chevron, I would click meets the requirements. Look at M1.0, right? So again, I can do all these different calculations within it to determine what I can add these extra notes to facilitate quick plan review. That's really what it's all about. And so then after I've got all the values in, or throughout the process, I can click check compliance. Now it's going to ask me, do I want to do the whole thing? Do I want to do one section, right? And I can choose those different options. Well, let's say I'm going to do the whole project, right? I'm at the point where I'm just going to click on the check. Here's another option. Here's a check, check compliance. It'll take me to compliance, and I can see those different areas of compliance, right? It's telling me that my building envelope will be 2.94% better than the minimum requirement. Remember, like I said, it's not going to tell me that my insulation's okay, because my lighting is okay, because again, it's not evaluating. It's telling me the values. It's showing me I've got an allowed, I've got a proposed, right? I've got an allowed, I've got a proposed. But again, it's giving me the information that I've input into the system, and then I can click on reports and get that COMCheck report printed out. Where I can see either the envelope, interior, exterior, mechanical, interior lighting, exterior lighting, mechanical systems. All of that information can be reviewed from either the ResCheck, the old COMCheck, the new COMCheck, or from even ResCheck, right? And ultimately what I've got is I'm going to get some kind of a bar, right? That tells me, how do I show compliance? Now, in comparing different code versions, remember, to go even from a 2015 IECC to a 24 Minnesota compliance process, again, I can design a building that again, I can use in multiple states, right? So let's say I've got my convenience store that I'm building in southern Utah, right? Which is a 2015 model for the. And so to move that building up, all I'm going to be doing once I change my code section, like my code that it's going to be compared by, I had to improve, the skylight. I had to add the insulation for the slab on grade, identify my controls, check my packages for efficiency that might be required. Those were required in the model codes and not in the Minnesota, so I had to take them out. They didn't help me anything, right? I had changed my efficiencies for different pieces of equipment. So again, when I start thinking about how does this look in the process, you can kind of get an idea of how COMCheck works. And then as I start to evaluate it, there's certain things I'm going to ask, right? Am I looking at the right code? Am I looking at the right year? Again, I'm going to be verifying. I'm going to zoom in here. I'm going to verify the location, right? That I'm in the right climate zone, that I've got the right project size. Are we looking at a 5,000 square foot building on COMCheck, but a 50,000 square foot building on the plans, right? It could be a simple mathematic, because again, these are all input values. Maybe somebody missed a zero, right? But if it's 5,000 square feet versus 50,000 square feet, it will have an impact. We start talking about the size of the building, right? We can see this one here. It's got the green bar, and it's meeting the requirements of the code by 2%. So I've got a little bit of error of space for error in installation or maybe product selection, but ultimately I need to make sure that everything matches, right? It's not good enough to say, well, hey, yeah, they got a green bar, we're good. Now I need to start verifying my cavity and fenestration values, right? I need to go to each of those wall systems and say, okay, this is all part of the north wall. So I'm looking for a 19 bat with a 7.5 continuous, right? I'm looking at an R30. Now, we just talked about this, right? I can get an R30 roof insulation and still pass by 2%, right? Because I've done other things at other places. I've increased other values. I've added additional, insulation, or changed utilize those expectations for the windows or doors, right? We'll have to add more insulation in one area to put less in another. And as long as the envelope passes, we're all good. That is correct. So the question on the chat is, so COMCheck allows the designer to add more insulation in one area, example being exterior walls or R21 versus the required 13 or 19, to put less in another area, saying let's go with slab R10 versus R20, as long as the entire envelope passes as a whole. And the answer is yes, because what we're doing is that's the trade-off. If we were following prescriptive table only, then they have to meet those tables. By providing this level of trade-off, we can get in and say, hey, I'm going to reduce my roof, but I'm going to improve my envelope, my walls, different situations and things like that. But what I need to do as a plans examiner is make sure that what I'm seeing on that COMCheck is what I'm seeing in the building. So when I go to that wall system, they can have all the flexibility they want. So another question came up is when we're renovating an existing commercial building, what is the trigger for the amount of work that would require a COMCheck? Remember, COMCheck is a path, so it's an alternative, it's a resource. So you could do it on a 5-foot wall, and it would still do the mathematical calculation for you, right? So you can use it at any point. What is this performance simulation specs? I think if I understand the question, it's where is it's pulling that information. I think it's pulling it from Appendix C. I have to double check if I understand the question from the person online properly. But again, that value of what it's comparing for that reference design, that budget U factor you see on the far right side, that comes from the code itself. The code itself, and my brain is drawing a blank, but it comes from the table. I think it's in section C, Appendix C. Will actually give that list of all of those different U factors. If I'm wrong, I'll tell you I'm wrong. But but there's a table in the code that actually tells you what those default values are for comparison. And again, when we start looking at this wall, just remember we're looking for a 19 and a 7.5. And because let's look at that bottom window, I'm more efficient than what's required. I can then reduce insulation somewhere else. So if I start looking at my wall system, I zoom in and I see that I've got a 19 bat with a 7.5 continuous, right? I go up to my roof system. That R30 is going to be a 5 inches of poly iso insulation, right? Which again, we said it was going to be a R30, not an R49 and R60, an R30, because again, we've traded one off to get one somewhere else. And we can also, one of the things that is interesting is there's even insulation that's not identified in our COMCheck that we could calculate, right, for the fiberboard insulation for the thermal break, right? This, I mean, it's R1.3, but again, it could have an impact. But again, we're not even incorporating it in that design, right? Again, another example here is I'm going through those systems and saying, okay, do all of my wall values comply with the design in my COMCheck? R19, 7.5. Clarification, have been subpath only exists for section 5 for the envelope. When used in 610, it's only verification to allow compliance with. Correct. Right. So the clarification, again, like we've talked about, this is all about the envelope. Number 5.6 in our code. Jumping back up here to slide number, nope, that's not it. 5.6, right? This is that trade-off that we see identified as that alternative for the building envelope. Now, like I said, when we start putting in those values, because we're doing, all we're doing is putting in one place all of our mechanical and lighting values. That's just a tool, just another way to give us quick access to the values, right? But what we're really using COMCheck for is this process of verifying, does the wall match what's in COMCheck, right? Do I have a, let's see where we got our insulation. And see, I think this is another example where we don't have those values identified, right? So I've got a 1.5-inch continuous rigid insulation. What is that? I don't have a value. I've got R19 bad insulation. Now I need somebody to verify that this is the proper R value of this rigid insulation, right? So this is when I'd call back and say, hey, I need to verify, is that 1.5 inch equal to 7.5, right? Here's another one where we've got, again, below grade slab, and we're installing this thermal break associated with that slab. But if you remember, I think we put on that slab, zoom back out. This is the fun part, right? That slab, well, it has no insulation listed, right? That unheated slab on grade, 0 insulation. So again, you can move things around, and there might be some elements. I was looking at one where they had listed that slab. It was actually listed at 30R around the slab, and I had to call them and say, hey, I think your 30 might be a little off. Are you really going to put 6 inches, 5 inches of slab insulation? No, made a mistake there, copied it over. Okay, we just want to make sure, because that's going to affect how compliant you're going to be. And so if I have to walk over 6 inches of insulation to get in the front door, it might be a problem for a building owner. Again, similar expectation here. We see that we've got listed those window values, right? You see the window values 0.42, 0.32. And now we need to make sure that we have those values in our door schedule. And one of the things that we're going to see, we've talked about this when we talked about windows last week, is I don't see those values, so I'm going to need additional clarification. I need to verify that the windows identified in this design, in this schedule, match the windows identified in the COMCheck. Because again, it's part of that system. This is where I'm going to get that inspection checklist that we talked about earlier, where they've put in those notes that says, yes, it will comply, and here's where you're going to find it, right? This is something that I, 9 times out of 10, just throw out, because again, if it's not fully filled out, then I've got my own checklist that I'm looking at. But some people will use it. And again, some designers will pre-fill it in order to, again, expedite plan review. If we're looking at mechanical systems, I know we're going to talk about mechanical systems in more detail next week, but looking at it from a COMCheck perspective, like I said, this is not a test. This is more of a tool, right? So we're verifying the code, verifying the climate, verifying the equipment. But in that equipment, it's just giving us the value of the information. It's not testing anything. It's really just saying, they said this is what it is. It's a quick reference guide for the mechanical design, right? And so if I start to evaluate, and so I'll still have to evaluate each one of those pieces of equipment, looking at their heating requirements, to verify that they have the appropriate efficiency listed, as well as the cooling requirements, right? And what I'm expecting to see in each one of those systems. Because what we're going to find out is that, while the code is going to be tracking this required efficiency, just because I put down 15 SEER doesn't mean that piece of equipment actually is. I need to verify, look at that equipment schedule to make sure it matches what's being presented. Same thing when we've talked about exterior lighting already. We're going to talk about interior lighting in a couple weeks. But again, I'm going to do the same thing. Verify my code, verify my area matches, right? That they didn't tell me this is a retail and then they light it up like it's, a penitentiary, right? And then I'm going to see where it comes in on compliance. Remember the number of fixtures. I've seen projects before where they've miscalculated, again, because of the relationship between the lighting contractors and maybe the person doing the final report. Is this going to be 215, lighting fixtures, or is it going to be 130 receptive lighting fixtures? That will change because, we see it passes by 49%. Well, if that's assuming that's all the lights that are there, right? If there are more lights than what we've got identified, then that's going to create part of that problem. So again, that's where we verify that. We'll talk more about that when we get into the lighting design. Same thing for exterior lighting, right? Do they provide that information? Like I said, you can use that information to say, okay, you've got all these controls. We'll talk more about interior lighting later, but again, this is something I can use that lighting COMCheck report to say, they said they were going to have 43 of these lights in here, and I'm not seeing 40 lights. I'm seeing 80 lights. I'm seeing 5 lights, right? Same thing with, and again, going over and saying, some of these are relatively easy. Let's look at this one here. I see the LED strip light that's identified there. There's 14, but they're proposing 33 of them in the schedule. So that's going to be a difference, right? You've more than doubled the number of lights that are going to be outside or going to be used. And so again, I need to make sure that those numbers match side to side. And the same thing with those exterior lighting, like we talked about. What matches in the field and out in the field. Now, I know we went through that pretty quick. Anybody have any questions, any other additional clarification, things we want to look at one more time? I know we got a few minutes, and I've always got more slides, but I want to give you an opportunity to ask questions. Now, again, here's another example of another project following that same methodology, right? Different project. We're going to be looking at those same areas, verifying that same fenestration details. Let's zoom in. So see, this one's giving us a lot more different wall designs. This one we're looking for a 19 and a 13 on the exterior steel frame wall. Then we've got some elements where we've got 24 continuous only. And so depending on our design, we've got our 19 and our 13, right? 19 fiberglass, 13 rigid. And up here we've got an R62 rigid insulation for the roof. But when we look at what our roof value was 58. So what does that mean for us, right? That means they put more insulation than required. Now, to me, that's one of those things I probably wouldn't, if that was the only thing on this plan review, at the end of the day, I probably wouldn't, again, I would make a note and approve it, right? That, is this, the installation starts at 62 and averages 58 over the course of a slope, or what's going on? Because again, that could affect, that probably makes the heating system a little bit more efficient than was originally designed. It's kind of a small 4R, over the course of a roof system. But again, we're verifying that all these systems match. Let's see, keep going. Same thing with the equipment. This is again, they've identified the equipment. The code's not doing any verification for me. I need to do the verification myself. So I start to identify, I take the first one, it's a ground source heat pump. I take the heating load capacity, of that system. I move it down. Oop, there it goes. I verify that 2.5 COP that was listed earlier, right here, that requirement of 2.5 COP, coefficient of performance, is the appropriate minimum efficiency. They've identified a 4.2 system. Again, same thing when it comes to the cooling expectations. There goes the stupid. There are times I really don't like the arrows, right? So I've got my cooling, it's 12.1. My cooling down here is 12.1. And so when I start to look at the equipment, I can look at that equipment schedule, zoom in. I can see that my coefficient, my energy efficiency ratings, my coefficient of performances. I'll zoom in closer, bring it, right? So I can see it was telling me it was going to be 15.3. It was going to be 4. And so again, I can verify those values so that the COMCheck is not doing anything. It's just giving me that for mechanical systems, it's just giving me the information. Is required. So the question in the chat is, is a clarification I think is important for us. Yeah. So it says prescriptive path without trade-offs. COMCheck is not required. That's correct. Right. So if we're using section 5.5, we do not need to use COMCheck. All right. We're going to use just follow the table, put the right insulation in. When we're looking at the COMCheck is one method of demonstrating the trade-off for section 5.6. It's not the only method. We can do other methods there are other systems. This one is just free, which is why most people use it. Then it asks the energy cost budget and the performance measures use different software for simulating that energy calculation and documentation, but they can use COMCheck for documentation as well. And that's true, because again, what we're looking at is you can use this system, you can do the math calculations and still run a COMCheck at the end. This project here was doing an energy cost budget analysis, the one we're looking at on the screen. And then you can actually, you can use it, you can run that energy cost calculation and then come back with the COMCheck and say, hey, this is probably simpler than 38 pages of energy paperwork. So one of the questions is the presentation slides going to be available? Yes, always. I'll put them in the chat again just in case people came in late, sure than when I first put them in. But yeah, if you have any more questions, let me know. And so again, we're looking at the mechanical systems, looking at the lighting, looking at again, here we're looking at the lighting requirements for this school unit. We've got all the items identified, all the fixtures. Now we start identifying, you can kind of see identified in this great, we'll talk more about interior lighting soon, but again, we see identified all of our lighting control zones, right? Our day lighting control zones. We see identified our specific lighting fixtures with, that are identified in LC6. It's on one of these items here. I think it's this one here, right? So it's identified. We can verify it on both the schedule and the plan to say, yes, you've identified, I'm going to use this, 4 of these. Oh, let's zoom in because I'm reading from far away. LC4. Right? I'll see it listed there. Sorry, back and forth. Giving you seasickness there. But again, so we can use this for different ways. We'll talk more about the interior and exterior lighting again that we see here. Some different items identified. Here are some pole lights. It tells me there are 6. Sure enough, there are 6. Right? It tells me there are 2 of these little blue lights. There are 2 blue lights at these entrances. So again, I can verify that what's on the plan matches what's in the COMCheck throughout this process. Now, if you do have questions, always feel free to reach out to us through the helpline. Please use your survey to put any potential topics that you think would be helpful. We're starting to think about things for the second half of the year. We will continue our plan review and inspection series through the next 6 months as well. But we are looking for a little bit more, what would be fun topics to bring up or questions that you might have to get us through. Next week, we're going to start into our plan review, or not into our mechanical system design discussions. I'm going to be working on sending out CEUs tonight or this afternoon. And if you aren't already signed up but might be interested in attending this free 2-hour discussion webinar on the differences between and the ask the experts about continuous and bat insulation, feel free to check that out. It should be available. You might have received emails about it. If not, feel free to reach out to us if you have any questions. And like I said, if there's anything that we didn't answer, if there's a burning hole, a burning question out there, feel free to email us, and then we can always send out supplemental information. Everybody have a safe week. Be careful. Hopefully the weather is breaking and we can all get outside and do inspections together. I'm just kidding. But if you have any questions, feel free to reach out to us.